If you imagine a molecule of one butanol where you've got 4 carbons in a chain attached to an O and then attached to an H, and all the other carbons are saturated with hydrogen just for ease. This OH molecule that is attached to the end of the carbon chain, this is known as a primary substituted alcohol. Now, substituents and substituents of carbon chains, alcohols, amines, etc., 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 that's going to be the topic of this sort of science-based video. But if to go back to the molecule of butanol, if you imagine a molecule of 2 butanol instead of 1 butanol, this 1 and 2 difference means that the OH group is placed at a different point on the molecule. So you're going to have the carbon chain of 4, and then the OH is going to be placed off of a carbon that is a carbon in. So that means that the carbon that is bonded to the OH is now bonded to 3 things that are not hydrogen. So that carbon is now substituted 3 times with things that aren't hydrogen. That alcohol, the OH group, that is now a secondary alcohol. It's not like a tertiary or 3 alcohol, 3 degrees sort of alcohol, because it connects to a carbon that's connected to 3 other things, because one of those things is itself. If you imagine the OH is bonded to a carbon, if that carbon is bonded to 2 hydrogens, it's going to be a primary alcohol. If that carbon is bonded to 1 hydrogen, it's going to be a secondary alcohol. If that carbon that is connected to the OH is bonded to 3 carbons, because it can't bond more than 4 times, considering that OH is one of its bonds, that is then a tertiary alcohol. And the same thing is going to apply to many other functional groups. You've also got things such as amines. Amines contain a nitrogen. If you've got a nitrogen, if it's on an organic molecule, it has to be connected to a carbon. So that's going to make it a primary amine if it's connected to a carbon and then it's connected to 2 other hydrogens, because nitrogens can only form 3 covalent bonds, so that's why it's going to be 1 carbon and 2 hydrogen. And so if that was then bonded to 2 things that were not hydrogen, it would be a secondary amine, and if it was bonded to 3 things that are not hydrogen, that's then going to be a tertiary amine. If you imagine a ketone as well, a ketone is sort of symbolized as a C, double bond to an O, and because carbon can form 4 bonds in total, it's already got 2 bonds connected to the oxygen, so it's going to have 2 variable R groups, which can just be anything. If one of those R groups is an H, then it's actually a separate functional group known as an aldehyde. So the whole primary ketone, secondary ketone doesn't really apply to some functional groups. It's only really functional groups where the carbon that the functional group is connected to, when it can have sort of different things attached to it, because it's not like a double bond or anything like that. If it has more than 3, I'm pretty sure, or something like that, then it's going to have the whole primary, secondary, tertiary thing. You can have something like an amide, which is a carbonyl, which is then bonded to a nitrogen, and there's 3 variable R groups. You've got 1 coming off the carbon, because it's only bonded to 3 things, and 2 coming off the nitrogen. If all of these things were H's, then it's the most simplest amide that can possibly exist. If one of them is substituted with the carbon, then it is a primary amide. If 2 of them are, secondary amide. If all 3 of them are, then it's a tertiary amide. These things exist in loads of functional groups. So you've got something like an amide has 3 variable R groups, and they're all functional groups that exist inside of organic chemistry. But not only that, you also have the carbons themselves that can be substituted. If you look at a molecule of methane, a carbon connected to 4 other hydrogens, fully saturated carbon, can't have any more hydrogens attached to it. If just one of those hydrogens is substituted with a carbon chain which can have anything else attached to it, it could have a benzene ring, as long as it has a carbon that is attached to something else, that doesn't really matter, because it's the carbon that is substituted, that is what matters. That is then a substituted carbon. It's substituted 1 time. There's no word for like 1 or whatever, so it's just a substituted carbon. Then if there was 2 carbons coming off, so now it's 2 hydrogens coming off it and then 2 carbons, or it doesn't have to be carbon, it can be another functional group. For instance, you've got something like chloroform, which is it's got 1 C, and then it's got 3 Cls, chlorines, coming off of it, and then an H. That's a tri-substituted carbon, but the carbon itself isn't necessarily substituted to carbon chains. It can be other functional groups that as well, instead of just a carbon chain, that can be substituents. But if you have all 4 H's replaced by another functional group or a carbon chain that can have other functional groups on it, or not potentially, then it is a tetra substituted carbon. Tetra, a funky word, probably wouldn't have heard of it before unless that's based off of Latin and you've done Latin before. I don't really know. But yeah, that's how substituents work in organic chemistry and stuff like that. You've also got things like isomerism and stuff, which in some cases I think is related to substituents. I'm pretty sure there's one really complicated isomerism known as chiral isomerism, which is where the molecules can't be superimposed on each other. And even though they have the same molecular structure, and if you looked at them like the mirror image, they'd be the exact same because they're a mirror image of each other, but they can't be superimposed. So just like your hands, basically, you can't sort of superimpose your hands, but they're exact mirror images of each other. It's like, it makes sense when you sort of say the definition, but when you actually put it into a practical chemistry sense, it's really confusing. But hopefully there are other videos on that you can sort of go down the rabbit hole on, because sometimes I feel like I make these videos for people to just binge and just go on the rabbit hole down, because that's kind of a fun thing to do sometimes. But with that, I recommend subscribing, because I like this community of young tribal people who are willing to improve themselves. So much more than we already have, and good luck.